Welcome to Calculated Education. Today we're taking a look at an SAT, ACT math practice problem. Here we're taking a look at an example 2. Here it says the graph of y equals 3x plus 9 times x minus 5 is a parabola in the xy plane. In which of the following equations do the x and y coordinates of the vertex of the parabola appear as constants or coefficients? Now, there's only one way we can write a quadratic equation in terms of its vertex, right? And we can recall this from algebra. It's going to be y equals a times x minus h squared plus k. So we want to see which equation abides by this rule here. And I think it's pretty straightforward if we take a look at it. The only answer here is C, right? It's the only one that has that same formula and the same constant. We have 3x minus 1, etc. And so what we're going to do actually is we can take a look at this by expanding our equation and then reducing it if we'd like. So they also call it completing the square. It's up to you what you prefer, but let's just say y is equal to 3x plus 9 x minus 5. This will be a little bit quicker as I FOIL out, but I'm going to have 3 times x, so it's 3x squared plus 9x minus 15x, and then a negative 45, right? Negative 5 times 9 is 45, so we're going to subtract. So that gets us with 3x squared plus 9x minus 15x is going to be actually a negative 6x minus 45. And so when we complete the square, we say this is equal to 0. We want to move this constant 45 over. So that gives us 3x squared minus 6x plus some constant is equal to 45. All right, I'm going to say plus some constant here. And in this case, how do we make this equation true? One of the best ways we can do that is by, if we take the 3 out, let's say we're going to multiply 3 times everything, x squared minus 6, 3 divided by 6 is 2x. Okay, then what do we have to have here as our constant to complete this, to make this true? Right, so if we know we have to come up with 2 factors. So if I'm going to get negative 2x, that means I have to have 2 negative values here, most likely. And then if they're 1, what does that mean? If they're both 1 times, negative 1 times negative 1 is going to be a positive 1 here. All right? But in reality, remember, we're multiplying it by 3. So we have to make sure if we're going to add 3 here, we need to add 3 here as well. All right, so let's put this all back together in our format that we need it to be. Remember, this right here is equal to this, which is equal to x minus 1 squared. All right, so we're going to substitute that in. So we're going to have 3 times x minus 1 squared. And then we want to move, since it is negative 1, and then we're multiplying that by 3, it's going to be actually a negative 3. My apologies, is what we'll be adding to both sides. To both sides, correct, is negative 3. So we're going to subtract 48 to get us back to our original. So if we subtract, we're going to be adding negative 48, and that's going to be equal to 0. Right, so that's going to become our new equation. Y is going to be equal to 3x minus 1 squared plus negative 48. I know it's a little quick, it's pretty rapid, but our whole process is we want to make it into this equation here with our coordinates being h and k. And what you want to do is you want to complete the square, so you subtract your constant over onto the other side. And if you're going to add 3 to one side, you need to add it to the other, right? Because in order to complete the square, we added 3. And then we wanted to get it all on the same side of our equation, so we subtracted to get 48 on the right-hand side of our equation, which ended up being equal to y. If you have any questions or want to see your questions answered, email them at calculatededucation@gmail.com. Or if you need additional tutoring, you can reach out to that email address as well. Thank you.